Welcome, class. Today we will be talking about how to prove angle pair relationships. It's pretty much an extension from the last video, except for now we're going to be focusing on some angle pairs, so complementary, supplementary, linear pairs, vertical angles. All these will be something we will be trying to prove in this section. We'll start with theorems 2.3 through 5, and if you remember from last time, theorems are something we can prove. If I wanted to, I could prove to you theorem 2.3, 2.4, 2.5. In fact, I believe 2.3 and 2.4 end up being in the book, in the notes, if you really want to see them. They say all these have titles, so you'll probably be using them again. Theorem 2.3 is the right angles congruence theorem. All it states is all right angles are congruent. If you remember either the phrase or the name of the theorem, either one will work for me. If you remember it's theorem 2.3, that's great. However, I prefer if you remember it as right angles congruence theorem, because different books actually label the theorems differently. Theorem 2.4 is congruent supplements theorem. That just means if two angles are congruent to are supplementary to the same angle, that means they are congruent. So if angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, well, angle 2 is supplementary to both angle 1 and 3. Therefore, angle 1 and 3 have to be the same angle. Similarly, you can make the same argument for congruent complements theorem. And just instead it says about complements instead of supplements. Alright, example 1, our first proof. Prove that angle 1 is congruent to angle 3. And you know that angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary. They were even as kind to provide us with a diagram here. Very first part of every proof is you write down what you are given. Seeing I'm trying to prove angle 1 is congruent to angle 3, that better be my last step down here. However, angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary. That's the given. I can combine it into one statement. However, I could have made this a 1 and then a 2, and then I had a 1 and a 2 both being given. It's really up to you. I don't see any reason not to put just 1 here and list every single given in one time. Remember, after I list the given, I have two options. I can either change what I have above, or I can do something like angle addition postulate or segment addition postulate. If I tried that method though, there's not really a nice way to do angle addition over here, and this one you can't even attempt to do angle addition because that would be technically illegal to do. However, I can change something about angle 1 and angle 2 being supplementary. If they're supplementary, that means their measures add up to 180. I'll say that. Similarly, the other part of my given, I could say measure of angle 3 plus measure of angle 2 is 180 degrees. For both of these, I will say, well, if they're supplementary, that has to be true. So that's really what it means to be supplementary. And if it's what it means to be supplementary, that means it's the definition of supplementary angles that allows me to do this. After I get here, I'm trying to show that angle 1 and angle 3 are congruent. I have some information here. They're both equal to 180. That does sort of hint at times that I might be setting measure of angle 1 plus measure of angle 2 equal to measure of angle 3 plus measure of angle 2. And sometimes you're just taking a shot in the dark here with what to do next. For me, I do see a little bit of a plan. If I set these two globs equal to each other, I have measure of angle 1 on one side and measure of angle 3 on the other side. And if I can get rid of measure of angle 2 from both sides, well, I'm getting closer to where I want to be. So, the shot in the dark, let's combine measure of angle 1 plus measure of angle 2 to equal measure of angle 3 plus measure of angle 2 by going through this middle domino. And that, if I go that way, is the transitive property. I got rid of that 180 between them. Yeah, the 180 is the connection between these two, so I could say these are equal. So that's why it's a transitive property. Now that I'm here, I'm trying to get measure of angle 1 equal to measure of angle 3. So if I subtract measure of angle 2 from both sides, well, measure of angle 2 is just a number. So I can subtract them from both sides and get measure of angle 1 equals measure of angle 3. And that was just subtracting measure of angle 2. So the reason is subtraction property. And at this time, if I have two measures equal to each other, that means those angles are congruent. So angle 1 is congruent to angle 3, exactly what I was trying to prove. And the reason I can say it is because that's what it means to be congruent. For angles, at least, is that their measures are the same. Definition of congruence. Alright, now that we have gotten our first proof out of the way, postulate 12 and theorem 2.6 are the next two things we need to talk about. Both of these have another name, so memorize the name. If you forget that it's postulate 12 is the linear pair postulate, it's not going to be the end of the world. But if you remember that the linear pair postulate says if two angles form a linear pair, then they are supplementary, that's all I'm asking. So if two angles form a linear pair, then they are supplementary. Remember, the official definition of a linear pair is that it's two adjacent angles that non-adjacent sides form a pair of opposite rays. There's nothing in there that says a linear pair is supplementary in its definition. So we had to come up with this postulate that said if it's a linear pair, then it is supplementary. Again, postulate, I cannot prove this to you, it just is. However, theorem 2.6, I can prove to you that the vertical angles congruence theorem is true, and that all it says is vertical angles have to be congruent. Remember, vertical angles are those angles that, so vertical angles in this case would be angle 1 and angle 2, the red angle and the green angle. And those two have to be the same size, so all vertical angles are congruent. Example 2 states that given that angle 3 and angle 4 are a linear pair, and that you know the measure of angle 4 is 112 degrees, I want you to find the measure of angle 3. We're going to practice a two-column proof for this, just because we can prove what the measure of angle 3 has to be. The only thing that I know for sure is that angle 3 and angle 4 form a linear pair, and I also combined, and measure of angle 4 is equal to 112 degrees. That's my given, always my first step. After this, I have seen people do this a different way, is that they just look at what is above and they modify it. So for instance, my next step here, if these two are a linear pair, that means they are supplementary. Angle 3 and angle 4 are supplementary. Okay, well if they're supplementary, that means that when I add measure of angle 3 plus measure of angle 4, that's 180 degrees. After that, I know that measure of angle 4 is 112 degrees. So why don't I plug in 112 for measure of angle 4? And after that, I subtract 112 from both sides. And I get the measure of angle 3 to be 68 degrees. Exactly what I'm looking for. But I haven't justified any of my reasons over there. All I've done is the work for why this is true. Well, from 1 to 2 here, I said that angle 3 and angle 4 form a linear pair. That means they are supplementary. That's not the definition of a linear pair. It's that linear pair postulate. If it's a linear pair, then they are supplementary. Well, then from 2 to 3, if I know these two angles are supplementary, I know that their measures add up to 180. That's what it means to be supplementary. If that's what it means to be supplementary, then it means I use the definition of supplementary angles. Then for 3 to 4, the only thing I changed here was that I substituted in or replaced measure of angle 4 with 112. Right here, I substituted or replaced substitution property. Then I subtracted 112 from both sides. Alright, if I subtract anything from both sides, you should know it's a subtraction property. Perfect. I proved it. I've given my reasons. You could follow this. And if you didn't know what I was talking about, you could look at the reason on how I got from one step to another. So your two methods are you could do each step one at a time, statement and reason, or you could just go through, do all the statements, and then go back in and feel how you can justify why you did that. I honestly don't care which way you go, but you have to choose one. Wow. Alright, the last example is section 7. Example 3. It wants us to find the value of x if measure of angle 1 is 3x minus 4 degrees and measure of angle 4 is 6x minus 184 degrees. And they give us this diagram here to refer to. Well, right away, I just copied down what they told me, that each of the measures of each of the angles given. At this point, I don't know what I can do with measure of angle 1 and measure of angle 4. So I look at my diagram and I see that measure of angle 1 and measure of angle 4, it just so happens that angle 1 and angle 4 are congruent angles. So that they're vertical angles. So why don't I say angle 1 is congruent to angle 4? And the reason I can say that is because I know that vertical angles congruence theorem. Vertical angles have to be congruent. Well, if the angles are congruent, that means their lengths are the same. So right away, after I say this, these two segments are congruent, I'm going to say measure of angle 1 equals measure of angle 4. That's what it means to be congruent angles. So definition of congruent, or definition of congruent angles. Alright, now that I have measure of angle 1 equals measure of angle 4, and I know that measure of angle 1 equals 3x minus 4, and I know measure of angle 4 equals 6x minus 184, why don't I get rid of this middle step here? This quantity equals measure of angle 1, which in turn equals measure of angle 4, which in turn equals this quantity. So why don't I just set 3x minus 4 equals 6x minus 184 and say it's the tipping of dominoes over. Transitive property. No problems there. At this point, I need to get all the x's on one side, so I subtracted 3x from both sides. Once I subtract 3x from both sides, well, that's the subtraction property. Alright, at this point I add 184 to both sides, addition property, followed by the division property. Divide both sides by 3. These proofs are about this difficult where you have to kind of modify what you have above. Sometimes you do something with vertical angles, sometimes you're doing the segment addition postulate, sometimes angle addition postulate, but either way, you're modifying either what you have above to get something that you need, or you're getting other information that you can see from the diagram. Segment addition, angle addition, vertical angles, linear pairs. You should be able to get all that information from looking at a diagram. And sometimes that's the missing step you need in a proof to be able to do it. If I did not have this vertical angle congruence theorem, I would have been stuck. I would have never been able to find find the value of x. I wouldn't have known what to do. But because I had a diagram that I could say something about, I was able to do this problem. At this point, you should be able to tell me what complementary and supplementary angles are. You should also be able to identify linear pairs and vertical angles. And you should be able to use any of the above definitions, postulates, and theorems to write a proof. You should be relatively decent at writing a proof at this point. Till next time.